Hi, my name is Ugo Okeke, and this is a presentation about using aspects of mechanical engineering to further develop and explore the Arctic regions. Energy is perhaps one of the most important things needed for the development of a region. The Arctic Circle makes up about 6% of the Earth's surface, yet it holds an estimated 22% of Earth's natural gas and oil resource. This untapped source of energy drives the industry to further develop the region. Unfortunately, accessing this resource comes with a very real risk of spillage. In 2010, the largest marine oil spill was caused by the explosion of the Deepwater Horizon oil rig. An estimated 4.9 million barrels of oil was discharged into the Gulf of Mexico, severely affecting plant and wildlife. British Petroleum paid $18.7 billion to settle claims, the largest environmental fine in U.S. history. In the wake of this event, Arctic nations have re-examined regulatory standards to prevent a similar disaster in the northern regions. A significant amount of gas and oil reserves lie offshore, and as Arctic sea ice melts, the vessels and rigs are able to reach the natural gas and oil below the water. But because the Arctic is such an underdeveloped region, a spill in its waters would result in a different and a harsher challenge. In August 2012, the Ocean Energy Safety Advisory Committee concluded that there is a need to modernize U.S. regulations to include Arctic-specific standards. These new standards would help to prevent, contain, and respond to any oil spills. Former Secretary of Interior Ken Salazar conducted a formal review of Shell's 2012 Alaska offshore oil and gas exploration program. The report concluded that the unique challenges of the Arctic region must be accounted for when designing the extraction equipment. The Pew Charitable Trust, an independent non-profit NGO, suggests a few changes to current standards. Vessels, drilling rigs, and facilities must be designed to withstand maximum ice forces, as well as equipment needed to control spills must be located in the Arctic. The melting sea ice allows for increased traffic in polar waters. An increase in traffic also means there is increased potential for collision and environmental disaster. The large marine life of the Arctic make it that much more difficult to clean up a spill, so preventions are even more necessary. Redundant systems such as double-walled pipes, double-bottomed tanks, and blowout preventers are another way to prevent spills. A double-walled pipe contains an inner pipe and an outer pipe separated by annulus. A leak detection system indicates if the inner pipe is leaking. A double bottom is a construction method where the bottom of a vessel has two complete surfaces, with one layer built higher than the ship's hull. This layer is able to form a barrier to water in case the outer hull is damaged. A blowout preventer, or BOP for short, is a large valve used to seal and monitor oil and gas wells to prevent blowout, the uncontrolled discharge of oil or gas from a well. BOPs help to cope with the erratic pressures from a well during drilling. Due to the importance of blowout preventers for the upkeep of the drilling rig and the safety of the crew, regular inspection and testing is very necessary. In conclusion, to further develop the Arctic region, we must ensure that the environment isn't greatly harmed. We can accomplish this by ensuring that there is an Arctic standard for offshore drilling, as well as using mechanical engineering aspects such as double-walled pipes, double-bottom tanks, and blowout preventers. All these methods can help to ensure that we protect the region from unneeded disaster. Thank you.